Hello, welcome back to Learn Physics. In today's topic, we are starting a new chapter, Laws of Motion. Okay, so till now we learned about our motion in a plane. Motion in a straight line we finished, and motion in a plane also we finished. Okay, related chapters. And now so the motion, plane also over, straight line also over. Now what are the laws of motion? Okay, while considering the motion, which are the laws we should consider? Okay, so we know how we can define motion. It is if the object is changing its position with respect to time and surroundings, then we can say the object is under motion. So what are the laws of motion? First, we are going to study about the Aristotle's fallacy. Aristotle's fallacy. So, what is this Aristotle's fallacy? So, he is the one who started the studies about the motion. Okay, when he was studying about the motion, he understood that if we are making an object, we are applying a force and making the object to move. Okay, then after some time that object is coming to rest position. It is decreasing its speed and coming to the rest position. So what he thought, if we need to continue the motion of an object with a constant force. Okay, if the object moves with a constant velocity, if we need to make the object move with a constant velocity, we need to give an external force always. We should give the force always. We should always give the force to make the object in motion. We require a force. Okay, so that is Aristotle's law. So as per Aristotle, always we should give an external force to make the object in motion. So an external force is always required. So as per him, according to him, we should always give an external force to keep the object in motion. Okay, so that was Aristotle. But whether it is correct? So to keep the object in motion, an external force is required. That is Aristotle's statement. But there was a flaw in this statement. So if we are observing an object simply, so in a layman point of view, that is correct only. See, if we need to make the object in a constant velocity or in a continuous motion, if we need to make the object, we should continuously give the force. But we know another force called the frictional force is there. Frictional force only is trying to reduce the motion, isn't it? Frictional force is coming into effect, and the frictional force is the one which opposes the motion. That is the reason that we need to give a continuous force to make the object under motion. If the object needs to move with a constant velocity or it continues its motion, it requires a constant force. If we are applying a constant force, that means it's a friction. Yes, in that surface friction is there. Friction is opposing the motion of the object. Because of that only it can't continue its motion. Okay, so then afterwards we understood that it is a flaw in his statement, because if it is a frictionless surface, no external force is continuously required to continue the state of motion. Okay, so that was the flaw in Aristotle's statement. Okay, so the next one, Galileo's statement. Next is Galileo's statement. So he did some experiments relating to this one. Okay, in an inclined plane and smooth frictionless plane and an inclination, he changed the inclination like that and all. He tried his experiment. Actually, he took one inclined plane like this and made the ball to move in this position. So he understood that if I am starting from this position, so the object will be reaching to the same height. If h is the height from here till the same height, the object will be reaching at the other end also. Like that he understood. Okay, then next what he did, he increased the inclination. Slope is increasing. While he increased the slope, he understood that time also it is moving with the same height. Okay, so it is moving in the same height it is reaching. Okay, so he understood that the height is constant throughout. If we are increasing the inclination, slope is increasing, that means yes, it is moving a larger distance. Even if it is moving a larger distance, the height wise it is same only. And next what he did is, he made the ball to move in an inclined plane, and then it is without slope, a straight line path. So he understood that if it is a friction, all these are in a frictionless plane. Okay, ideal situation only he is considering. Frictionless plane, while we are considering a frictionless plane, and the other side without the slope we are considering, the object will be continuing its motion that to a infinite distance. Like that he understood. Okay, so Galileo had given the explanation for inertia. An object will continue in its state of rest or uniform motion. Okay, so that if we are not applying any external force, the object has the tendency to continue in its state of rest or uniform motion. That property is called, it's a natural tendency of an object to continue in its state of rest or uniform motion. Okay, that is called inertia. That property is called as inertia. So if we are practically thinking also, see, if we are in a lazy mood, okay, see, we won't feel like doing anything. We want to sit idle, isn't it? So once we start enjoying our laziness, then to come out from that, it is very difficult, isn't it? We have the tendency to continue in that state of rest itself. Otherwise, see, during exam time, if we want to study, so more things are there to study, or if we finish our revision also, we will be having that tension, isn't it? So we will be always revising. So that also will be continuing. So the children, those who have it's a good ambition and they have the good thought process, they will continue with their studies in that way. And those who are in a lazy mood will continue in its state of laziness, isn't it? So same way, not only for us, in all the objects, even if it is a living thing or non-living thing, everybody has the tendency to continue in its state of rest or uniform motion. So that is known as inertia. The object will continue in its state of rest or uniform motion. That process, that natural tendency of an object is called as inertia. Okay. So the next one is Newton's laws of motion. So next, Newton's law. First one. So first I will state the three laws and then we will start explaining. Okay. First one. First law states that, Newton's first law states that every body continues in its state of rest or uniform motion unless compelled by an external force. See, if we are not giving any external force to an object, that object will continue in its state of rest or uniform motion. So the object will continue in its state of rest or uniform motion unless compelled by an external force. If we are not giving an external force, see, this board is over here only. See, if I am not applying any force to that object and trying to remove it, otherwise the object will be here only, isn't it? See, the chalk piece is over here. Okay, if I am not applying any external force to this chalk piece, then the object will be, so me or anyone, okay, not only me, anyone who is not applying any external force to that object will be in this position only, isn't it? So if it is in the motion, the same way the object will be under motion, then if we are not applying any external force to stop it, isn't it? So if we are not applying also, or the friction is not affecting also, if friction is there, then obviously it will stop, isn't it? After some time, because of that opposing force, that object will be coming to stop position. So every body continues in its state of rest or uniform motion unless compelled by an external force. If we are not compelling with an external force, every body will be continuing in its state of rest or uniform motion. So that is Newton's first law. Every body continues in its state of rest, continues in rest or motion, okay, in rest position or in motion, if we are not applying any external force, okay, that is Newton's first law. Now the second law. Second law states that the force acting on an object will be directly proportional to the rate of change of momentum. Force is directly proportional to rate of change in momentum. Rate of change in momentum. Change in momentum. What is meant by this momentum? Then only we can understand what is meant by change in momentum, isn't it? So now we are going to understand the second law. First we are going to study about momentum, okay? So what is meant by momentum? Momentum is the product of mass and velocity of the object. It is the product of mass and velocity, that is called as momentum, okay? So the momentum is defined as the product of mass and velocity. So momentum representation is P. P equals m into v. This is the formula for finding out the momentum, okay? So what will be the unit of momentum? SI unit of momentum is, see, mass is kilogram, velocity SI unit is meter per second. So the unit of momentum is kilogram meter per second. So what will be the dimension of momentum? Dimension of momentum is mass dimension is m. What is the dimension of velocity? L t to the power minus 1. So m L t to the power minus 1. So the momentum is the product, is the term which depends on mass and velocity. So what will be the after effect of momentum? First I am considering the one example. See, a car is at rest. Car which is at rest. It is hitting on a, it is at rest and it is here only, and while we are moving through this way, an object which is having mass m is moving through this way and we are hitting that car, okay, by mistakenly we are hitting the car. What will happen? Maybe we will get a small hurt over here, that's all, isn't it? So the car is at rest, okay, then the car is moving with a velocity or particular acceleration, it is moving, okay, it is hitting the man who is walking with the same speed. What is the difference between these two? See, if the object car is at rest means velocity is 0, isn't it? Acceleration also 0. Here it is moving in a constant velocity. What is the after? You can think what will be the difference between those after effect. These two situations, what will be the after effect? So as velocity increases, the momentum also will be increasing. As velocity increases, momentum also increases. So momentum is a term which depends on velocity. So another example I will tell you. So second example is, I am taking a bullet and throwing at you. So you will get a hurt, isn't it? Instead of that, from a piston, shooting a bullet, that if I am shooting, that bullet is coming with a high velocity, which is the muzzle speed of the bullet, isn't it? So that will be getting. So what will be the difference? The second case, the person will die because it will be yes. So that difference. So velocity increases, momentum also will increase. Okay. So that is, so as velocity increases, momentum increases. Now you understood these two situations. Now third situation. I am taking a small pebble. I am throwing at you with a particular velocity. Okay, and throwing at a person or anything. I am throwing to them and with a particular velocity. Okay, so the after effect will be, if mass is less, after effect will be less, momentum will be less. Instead of that, I am taking a big rock. Mass is more, then momentum also will be more. So now you understood what is the difference between these two. So momentum, how it is affecting mass and velocity. Okay, in the same way you would have seen that cricketer, okay, while they are catching the ball, how they will be catching the ball? They won't be catching the ball like this, they will be catching the ball like this. What is the reason? Yes, velocity after effect will be less if the velocity is decreasing. Yes, by taking time. As if velocity suddenly increases or suddenly decreases, what will happen? Yes, the after effect will be more. Okay, so we will be considering that one. Understood? So how the momentum is relating with the mass and velocity. So now we can go through the second law once more. See, a force acting on an object is directly proportional to the rate of change in momentum. So force is directly proportional to, rate means with respect to time. So if I am considering a small interval of time delta t, it rate of change in momentum is delta p. This is the mathematical representation of this Newton's second law of motion. F is proportional to rate of change of momentum. Okay. Now we are going to derive a formula for force from Newton's second law of motion. So from Newton's second law, how we can derive the equations of motion? If equation of force, okay, derive the equation of force. Derive the formula for force acting on a system. That is, so while we are telling about these forces, it is all these forces are, which kind of force it is? It is external forces. See, if an object is moving with a particular acceleration and the object is moving with a particular acceleration, but we want to make the object a little bit more speed, the speed we should increase. So can we make it in as a, can we push it from inside and make the movement faster? No, right? So to make the object under motion, we should give an external force. Only external force can make the object under motion. So if we are sitting inside a car and trying to push it from outside, whether is it possible? No. If we need to make the object in motion, we should give an external force only. Okay, so now we are going to find out the external force. What will be the force in the this required to move an object with a particular acceleration? So I am considering an object which is moving with a mass m. Okay, force act as per Newton's second law. We know force is directly proportional to change in momentum divided by time. Okay, for changing the proportionality sign, I am multiplying it with a constant k into delta p by delta t. But p value we know. What is the value of p? Mass into velocity. So F is equal to k into delta by delta t m into v. So mass is not changing with respect to time. Mass is a constant with respect to time. So we can take it as m into delta v by delta t. So what is delta v by delta t here? It is acceleration. K into m into acceleration. Delta v by delta t is acceleration. But experiments shows that the value of k is equal to 1. Therefore, we got the value F equals mass into acceleration. So the force F is equal to m into a if the object is having a constant mass. Okay, if we are considering an object which is having a constant mass, then force is equal to m into a. Okay, clear now? So if we are not applying any external force, so F is equal to, if F is equal to 0, so ma is equal to 0. Isn't it? ma equals 0. But we know m will never be equal to 0. Mass will be there for an object, isn't it? So a can be equal to 0. Then the object will be under constant motion. See, v is constant, uniform velocity. That means the object will be under uniform motion also. This is what we said in the case of first law, isn't it? If we are not applying any external force, the object will continue in its state of rest or uniform motion. If the object is under uniform motion, the applied force is equal to 0. This is how we will be deriving the first law from second law. Okay, so clear? So if we are not applying any external force, then the velocity is constant. That means velocity, the object will continue in its state of motion, or if it is at rest, it will continue in that rest position itself, isn't it? So if we need to represent this in vector form, force is a vector quantity. Okay, so to represent it in vector form, F is equal to mass is a constant, ax I cap plus ay j cap plus az k cap. Like that we can represent in vector form also. So understood? Clear about this? Now we are going to study about the third law of motion. Okay, now the third law of motion is, every action there is an equal and opposite reaction provided the action and reaction should happen in different objects. Okay, so here see, I am able to walk, isn't it? If while I am walking through the road, see, I am applying an force downwards. That means towards the earth. So earth is giving a reactional force. I am giving a force in this direction and reactional force is giving in the opposite direction. That reactional force is helping me to move forward. Okay, so for every action there is an equal and opposite reaction provided the action and reaction should happen in different objects. Okay, so if A and B are two objects, force acting on, if I am acting a force on, if A is acting a force on B, then B will be acting a force on A, isn't it? But it will be in opposite direction. Direction opposite means it will be negative. Okay, so for every action there is an equal and opposite reaction provided the action and reaction should happen in the different objects. Okay, so that is Newton's third law of motion. Okay, so many examples are there for this Newton's laws of motion. That is mainly for the second law. So while we are getting down from a boat, okay, so boat will be giving a force on to the water and the water will be giving a force to the boat, and that reactional force again coming to us and will helping us to move out from the boat. Okay, and the recoil of a gun. See, while the gun, we are from the gun with a particular velocity, the bullet is moving, the gun will be giving a backward motion, isn't it? So that is why the soldiers and all will always be keeping the gun at the chest and they will be giving a shoot at that time, isn't it? So that is the reason, because of the reactional force. Okay, so next we are going to study about another term called the impulse. Impulse is the force acting on a short interval of time. Large force acting on a short interval of time. That is called in a short interval of time. Short time interval. That is called as impulse. So the large force acting on a short interval of time is called as impulsive force. So impulse we can measure it as force into short interval of time. That is called as impulse. Impulse is the force into short interval of time. That is impulse. But as per Newton's second law, we know F is equal to K into delta P by delta T, and this K value is equal to 1. So what is this F into delta T? That is equal to delta P. That is equal to change in momentum. So to calculate the impulse, we can find out the change in momentum also. So impulse is force, large force acting for a short interval of time. That is called as impulse. Okay, so it is large. So impulse depends on that force acting on the object and the interval of time. As interval of time increases, the force affecting on the object also, the effect of force, that also will be reducing. Okay, if we are a short interval, if the time is reducing, effect impulse also will be more, isn't it? So if we are applying the what is meant by impulse? Impulse is force acting on a short interval of time. Okay, that is called as impulsive force. Clear? So next we are going to find out what is meant by conservation of momentum. Conservation of momentum. Conservation means saving, isn't it? Or it is we are conserving nature, and conservation of energy also you would have studied. Now here we are going to study about the conservation of momentum. So conservation of momentum means momentum is not losing anywhere. That means momentum before collision and after collision will be same. That is called as conservation of momentum. So if any process is happening, before that process and after the process, momentum will be a constant throughout. That is conservation of momentum. Now we are going to derive an equation, or we are going to prove the momentum as a conserved quantity. Okay, so here I am considering two objects, A and B. Okay, let Fa be the force acting on A and Fb be the force acting on B. Okay, then Pa is the momentum and Pb is the momentum of B. Okay, after collision, both are colliding each other, and after collision, P dash A is the momentum of A and P dash B is the momentum of B. Collision is happening for an interval of time delta T. Then we know that as per Newton's second law, F is equal to delta P by delta T. So F into delta T equals delta P, isn't it? So the collision is happening for delta T time interval. So force acting on A into delta T equals change in momentum of A, that is P dash A minus PA. What is force acting on B into delta T will be change in momentum on B, PB dash minus PB. Okay, so now if we are, but we know FA will be equal to minus FB, isn't it? So while we are substituting that over here, FA equals P dash A minus PA divided by delta T. FB equals PB dash minus PB divided by delta T. Okay, FA equals minus FB. That means P dash A minus PA divided by delta T equals P dash B minus PB divided by delta T into minus 1. This negative is there, right? So it will be minus PB dash plus PB divided by delta T. So these delta T are same on both the sides. So we can cancel that one and we will get it as P dash A minus PA equals minus PB dash plus PB. Isn't it? So I am taking it together. This negative value, everything I am making it as positive. So this minus while we are taking to the left side, it will be plus, and this minus when we are taking to the right side, it will become plus. PB plus PA equals P dash A plus P dash B. So what is this P dash A plus P dash B? That is the total momentum after collision. Total momentum after collision. Isn't it? So total momentum after collision is equal to, what is this PA and PB? Total momentum before collision. That is equal to total momentum before collision. So this is law of conservation of momentum. So understood, total momentum before collision is equal to total momentum after collision. This is how we are doing. Clear now? Next is equilibrium of particle. So what is meant by equilibrium? So that word will be familiar to you in chemistry, isn't it? So here for a particle, when we can say the particle is under equilibrium position, if the net force acting on the object is 0, net force is equal to 0, then we can say the particle is under equilibrium position. The net force acting on the particle is 0. So that means, see, this is F1 and another force, this is F2, and I am applying F3 here. Okay, so I am finding out the net total force is equal to 0. See, in this case, if I am considering, see here F1 and F2, what is the net force? We can find out using parallelogram law. So I am applying the parallelogram law. I am getting F3 in this direction. FR, resultant force I am getting in this direction. Okay, so FR, to oppose that FR, I have an F3 with me, isn't it? So F1 plus F2 plus F3 will be equal to 0, isn't it? So in that case, we can say the particle is under equilibrium. So the net force, if the net force acting on the particle is equal to 0, then we can say the particle is under equilibrium position. Okay, clear? So all of you understood what is the Newton's laws of motion. Actually this is an easy chapter, but next is there's friction and all are coming. So while taking that one, so next topic I'll be considering and said friction and the related laws of friction and motion through a curved line. All those things we will consider in the next class. Okay, so clear all of you? So I am winding up for today. So if you like the channel, please don't forget to subscribe. Okay, and thank you for watching. Bye.